Look, behind the closed doors of Plant 42 in Palmdale, California, there's a secret. And the Pentagon treats it with more security than nuclear launch codes. But it's not a missile. It's not even a sensor. It's a chemical compound, a liquid invisibility cloak that costs more than gold per ounce. And it's so toxic that one mistake, one tiny tear in a worker's hazmat suit, and they're looking at a life-changing hospital stay. This is the skin of the B-21 Raider. To the public, the Raider is this beautiful flying wing masterpiece. But here at Aerostratics, we see something else. We see a $100 billion industrial monopoly built on some of the most hazardous materials ever cooked up in a lab. Because, let's be honest, making a bomber the size of a house look like a bumblebee on radar, that's not just engineering. It's a chemical war against the laws of physics. Before we go further, I have to ask you, does it surprise you that the most advanced weapon in the world relies on paint more than it does on engines? I mean, we're talking about a $1 trillion program held together by chemistry. Let me know in the comments if you think that's a genius strategy or a massive vulnerability.
So, how do you actually hide a plane? It comes down to something called RAM, Radar Absorbent Material. Think of it like a black hole for radio waves. Most planes reflect radar like a mirror reflects light. If you send a radio wave at a B-52, it bounces right back to the receiver, screaming, "Here I am!" But the B-21, it drinks that energy. The secret sauce is carbonyl iron ferrite. These are tiny, microscopic iron particles suspended in a resin. When a radar wave hits them, they create a magnetic field that turns that energy into heat. But here's the kicker, and the part the Air Force doesn't like to talk about. To absorb the wide range of frequencies used by modern Russian S-400 or Chinese HQ-9 systems, that coating has to be incredibly dense, and the denser it gets, the nastier the chemicals become. We're talking about things like isocyanides and hexavalent chromium, the kind of stuff that can cause chronic respiratory failure, skin necrosis, and occupational asthma that never goes away. If you want to know how dangerous this stuff really is, you have to look at the history books, specifically the ones from Area 51. Back in the 80s, workers at that secretive base in Nevada started getting sick, really sick. Why? Because they were tasked with burning excess stealth coating scraps in open pits. It was the early days of the F-117 Nighthawk, and nobody really understood the long-term impact of aerosolized stealth paint. When those workers tried to sue the government, they hit a brick wall: national security. The formulas were so classified that the workers couldn't even prove what had poisoned them. The courts ruled that the government didn't have to reveal these state secrets of the chemicals to settle the medical claims. It's a heavy question, but do you think national security is a valid reason to deny veterans their medical records? I know it's a sensitive topic, but I'd love to see a respectful debate on this below. Where do we draw the line between protecting the country and protecting the people who build its weapons? The B-21 program was designed from day one to avoid this nightmare. Not because the chemicals got safer, they didn't, but because the Air Force realized that a bomber that kills its own maintenance crews is a strategic liability. In 2017, Northrop Grumman built a massive new specialized coatings facility at Plant 42. This is where the human element was finally taken out of the loop. On the old B-2 Spirit, crews had to spend thousands of man-hours manually applying ram tape and toxic caulk. It was a nightmare. But for the B-21, it's all robotic. We're talking about AI-controlled arms spraying this liquid precursor with a precision measured in micrometers. Why such precision? Because if that paint is even a fraction of a millimeter too thin, the radar signature spikes and the plane becomes visible. If it's too thick, the plane gets too heavy and loses its range. From a business perspective, this is a masterstroke. Northrop Grumman has moved from a labor-intensive model to a capital-intensive one. By owning the robots and the proprietary chemical formulas, they've created a service-based revenue stream. The Air Force doesn't just buy the plane, they buy a 50-year subscription to Northrop's chemicals.
Every time a B-21 needs a touch-up, it goes back to a Northrop-controlled facility. This is the strategics of modern defense. You don't just sell the hardware, you own the ecosystem.
But what's next? Because the world of stealth never stays still. While iron ball paint is the current standard, the next generation is already here: ceramic-based RAM. Traditional polymer coatings are fragile. They break down under heat, UV radiation, and even rain. But researchers at places like North Carolina State University have developed a ceramic precursor that can be sprayed on as a liquid. When it hits the air, it undergoes a chemical reaction and hardens into a solid, heat-resistant shell. This stuff can handle temperatures over 1800 degrees Fahrenheit. That is a game changer. It means the B-21 can mask its heat signature from Chinese infrared sensors while staying invisible to radar. Quick poll for the aviation nerds in the room. If this ceramic tech really works, does it make current stealth jets like the F-22 or F-35 obsolete because their skin is too high maintenance? Or is the Raider just in a class of its own? Type F-22 or B-21 in the comments to vote.
There's an Achilles heel here, though, and it's one that should keep the Pentagon up at night. These advanced chemicals and the sensors they protect need rare earth minerals: gallium, germanium, and specialized terbium. And guess who controls 80% of that market? China. It's a dangerous paradox. To build the very plane designed to deter a conflict in the Pacific, the United States is currently reliant on Chinese minerals. If Beijing cuts off the supply of these precursors, the B-21 production line at Plant 42 could grind to a halt in months. This is why we're seeing a massive shift in the 2026 defense budget toward domestic mineral sovereignty. Every B-21 that rolls off the line has a ghost in the machine, a digital twin. Inside Northrop's Hive facility, engineers can walk through a perfect virtual replica of every single tail number. This isn't just a 3D model, it's a living data set. Sensors on the actual aircraft feed information back to the twin, tracking how the stealth coating is wearing down in real time. Instead of stripping the whole plane for maintenance, which exposes workers to those toxic chemicals, technicians use augmented reality goggles to find the specific micro-imperfections. They perform surgical robotic repairs. This reduces waste, saves billions in costs, and most importantly, keeps the planes in the air instead of in the hangar. Now, let's talk about the money. Because even with all this high-tech wizardry, the B-21 has been a financial bloodletting for Northrop Grumman. In early 2025, the company reported a $477 million pre-tax loss on the first production lots. Total program losses are now climbing over $2 billion. Why? Because Northrop signed a fixed-price contract. They're the ones paying for inflation, labor shortages, and supply chain disruptions. But their CEO, Kathy Warden, isn't panicking. This is a calculated gamble. They're eating the short-term pain now to lock in a 50-year monopoly. Once they hit full-rate production later this decade, the B-21 will become the single largest revenue generator in the history of the company. It's the Amazon model applied to stealth bombers. Lose money early to own the infrastructure forever. While the US is perfecting the B-21, the rest of the world is racing to catch up. China's Xi'an H-20 is the elephant in the room. On paper, it looks like a B-2 clone, but reports from 2025 suggest Beijing is struggling with the exact thing we're discussing today, the chemistry. Stealth is 10% shape and 90% material science. You can copy the flying wing design, but if your paint peels off at Mach 0.8 or fails in the humid environment of the South China Sea, your stealth bomber is just a very expensive target. Then you have Russia. The Su-57 has been widely mocked for its visible rivets and inconsistent panel gaps. You can put all the toxic RAM paint you want on a plane, but if the manufacturing is sloppy, radar is going to find those edges. Russia's chemical industry has been gutted by sanctions, leaving them unable to produce the high-purity polymers needed for true sixth-generation stealth. In 2026, being a maintenance worker isn't what it used to be. At B-21 bases like Ellsworth Air Force Base, the crews are wearing more than just hazmat suits. They are wearing biometric sensors. The Air Force is monitoring their blood oxygen levels, heart rates, and skin temperature in real time. If the sensors detect even a trace of isocyanide exposure or heat stress, the system pulls them off the line immediately. If you were a mechanic, would you trust an AI-controlled biometric sensor to tell you when you're in danger? Or would you still be worried about what those chemicals are doing to you 10 years down the road? I'd especially love to hear from anyone who has worked in industrial maintenance on this one. The B-21 is a diva. It needed gold-plated hangars, multi-million-dollar buildings with perfect climate control just to keep the stealth skin from melting or cracking. The B-21 is a blue-collar bomber. It's designed to sit outside under a simple shelter. This is a massive strategic advantage. It means the US can move B-21s to austere locations, remote airfields in Australia, Japan, or even temporary strips in the Pacific without needing a billion-dollar infrastructure footprint. The new chemicals are designed to be resilient. They can handle rain, dust, and baking sun without losing their radar-absorbing properties. That flexibility is what makes the B-21 a true 21st century weapon. Adversaries like China are betting on low-frequency radar to find the B-21. These long-wave radars can sometimes see the physical shape of a stealth jet, even if the paint is working. But the B-21 uses broadband stealth. Its skin isn't just one layer, it's a gradient of different chemicals that absorb across the entire electromagnetic spectrum, from high-frequency fire control radars to low-frequency early warning waves. The B-21 just eats it all. It's like a ghost that can change its voice to match whatever frequency the enemy is using. The Air Force wants at least 100 B-21s. Some generals are now pushing for 145 or even 200. At a unit price of roughly $700 million, the math gets scary fast. But the procurement is only a fraction of the cost. When you add in the 30-year sustainment and operations bill, the robots, the toxic chemicals, the digital twin servers, the total B-21 program could hit $1.5 trillion. Is it worth it? When you look at the hardened and deeply buried targets in places like Iran or North Korea, the B-21 is the only platform that can fly in, loiter undetected, and strike with the next-generation penetrator. It's the ultimate insurance policy for a world that's getting a lot more dangerous. Look, the toxic chemicals on the B-21 are an uncomfortable truth. To keep America's strategic edge, we have to play with fire. But the Raider proves we've learned from the mistakes of the past. We've replaced human sacrifice with robotic mastery. That invisible skin protecting the aircraft, it's also protecting the very idea of air superiority. But I want to know what you think. We're spending nearly $2 trillion on a fleet of bombers that requires a hazmat suit just to touch. In an era of long-range missiles and swarming drones, is a manned stealth bomber still the ultimate insurance policy? Or are we just doubling down on a 20th century concept with 21st century paint? Drop a comment below and let's talk about it. I'll be hanging out in the comments for the first few hours to see your takes. And if you're a veteran, we'd love to hear your perspective on how the tech has changed. Thanks for watching Aerostratics. We'll see you in the next mission.